Let P be a point on the graph of x squared plus y squared is equal to 9. That's basically the equation of the circle that's drawn in the drawing, right? And then they say express the area A of the rectangle as a function of x. So we have this red rectangle. What they want us to do is to describe its area as a function of x, right? So what you want to do in all these building function problems is basically to say, all right, let's work with the geometric part of the problem. Use the formula that's related to that geometric concept. In this case, we're talking about the area of a rectangle, so we need to think about what's the area of the rectangle. Well, we'd say, okay, for all rectangles, the area is usually described as length times width. So that's easy enough to remember. And then from there, we can tell, because of the way that the circle is centered at the origin, that it appears the rectangle is, basically the length and width are bisected by the axes x and y. So in other words, when you look at this x-axis here, you can see that that's sort of cutting the width of the rectangle directly in half, right? And you can say the same for the y-axis, right? You can say the y-axis is cutting the length directly in half. And whether you call it length or width, it doesn't really matter, but you can tell that the sides of the rectangle are being bisected by the axes x and y. The reason why that's important is because then I can say, well, this distance from here to here, that's x, right? That's the distance x. And we can say that when we talk about this height here, that's the y. So when we talk about P's position, x comma y, that height here is then given as y, right? And the width here is given as x. But that's just this little half piece, right? So in other words, this little part here is y, and this little part here is x. That means I wanted to know the whole length of the rectangle. Wouldn't it be true that the whole length would actually be 2 of these pieces? So if that distance is x, then the whole length is 2x. So we should be able to say L is 2x. So this should be the same as L. And likewise for width, shouldn't I be able to say that the width then is 2 of those pieces? So that's 2y. So it should be 2y as well, right? So you should be able to say the width is 2y. And again, the choice of whether you're calling length and width, what I've called it length and width, it doesn't change the answer, right? Because whether you have 2x times 2y or 2y times 2x. It's the same ultimate simplification, which is to say what? 2 times 2 gives you 4, and then x times y gives you xy. So your initial function or your initial statement is that the area is equal to 4xy, which would mean we were done if we didn't have the y, right? The y is a problem because we're not supposed to have y in this function. So it says as a function of x, and y, of course, is not x. So what we need to do now is to substitute out the y. So we've used the geometric formula. We have the area described related to the drawing that we have, but we don't have a function of x. We have a function that has x and y in it. So we need to get rid of the y. Okay, so to do that, we need to substitute out the y. So we have this equation above, don't forget that says that the circle is x squared plus y squared is equal to 9. So we have an expression that involves y. Let's use that expression to our advantage. If we solve for y there, we'll have x squared plus y squared is equal to 9. We'd actually just move this guy over, right? Which would end up giving us y squared is equal to 9 minus x squared. And then from there, you would normally want to take the square root of both sides here, so you'd end up saying that y is equal to plus or minus the square root of 9 minus x squared. All right, fantastic. Now, here's the thing though. Our point P is in the first quadrant, which means that both its x and y components would be positive because in that quadrant, both x and y are positive. And because the point P happens to be in that first quadrant and they're positive, we can get rid of the negative part here. We can just say that the y is basically the same as positive square root of 9 minus x squared. All right, now with that expression for y, we can then substitute it into our function. So we can say, hey, that a is equal to, so we're just going to put this in for y, right? So we'll have 4x times the square root of 9 minus x squared. And that's it. We're basically done. We have the function. So we've basically expressed the area of the rectangle as a function of x. We no longer have y's here, and we have a statement for the area as a function of x. Now what this means is that if I give you a particular x coordinate for my rectangle, right? So if I decide where that point is going to be located based on what its x value is, you'll be able to tell me the area of the rectangle. That's a pretty nice thing to have.